Good morning to one and all. On the behalf of St. John Institute of Pharmacy and Research, I, Vaishnavi Yadav, a student of MPharm Quality Assurance, extend a warm welcome to each one of you to our 34th session of SCIENTIA. Before commencing the session, let's have a small video of our college campus. Now, I would like to commence our first session, which is entitled as Liquid-Based Formulation. It's a pleasure for me to introduce our eminent speaker of our first session, Ms. Apurva Ma'am. Ms. Apurva Ma'am completed her B.Pharm from St. John Institute of Pharmacy and Research, Palghar, and her M.Pharm in Quality Assurance, also from St. John Institute of Pharmacy and Research. She has 1 year of experience as assistant professor in St. John Institute of Pharmacy and Research. She has 3 publications in International Journal and 1 publication in the National Journal to her credits. She also has 1 publication in international as well as national magazines. She has professional membership as registered pharmacist with Maharashtra State Pharmacy Council. She also has many academic achievements. One of them is she has won first prize at Avishkar competition at UG category on the university level. With this brief introduction, I would request ma'am to take over the session.
Good morning, everyone. Am I audible? Good morning, everyone. Thank you for coming to my SCIENTIA session today. I am Apurva More, Assistant Professor, Pharmacy from Central Institute of Pharmacy and Research. Today, I welcome you all to my session titled Lipid Based Formulation. Today, we are going to see certain things which are there in the lipid based formulation. The contents of our slide, the contents of today's slide what are the lipid-based formulations necessary, what are advantages, certain approaches by which you can formulate the formulation, what are the different formulations which you can make. Then we are going to look at certain marketed products, we are going to look at certain items. We'll discuss a little bit about the regulatory compliances which are required, and then we'll conclude our presentation. Okay, to begin with the presentation, we are going to discuss about the lipid-based formulations. Lipid-based formulations are the formulations where you are using lipid drugs where the lipid maintain the drug in the solubilized form. These are usually formulated by dissolution of the drug in molten lipids, which are emulsified with water to form stable lipid-based formulation. The emerging trends in the combinatorial chemistry and drug design have led to development of drug candidates which are having higher lipophilicity because of their high molecular weight and poor water solubility. About 90% of the drug in the drug discovery pipeline and approximately 40% of the drugs which are in the market are poorly water soluble. As these drugs are poorly water soluble, an insufficient amount of the drug is reaching to the systemic circulation and at the site of action, which results in lack of pharmacological action and produce poor bioavailability. Hence, we have a need for the development of suitable formulation which can enhance the bioavailability of the drug to achieve desired therapeutic response.
Hello, madam, are you there? Hello, Apurva ma'am.
Disturbances. Okay, let's continue. Okay, so the criteria how you are going to decide which formulation you are going to make was actually given by Amidon and his co-worker. The classification system which we very well know is the BCS classification system, which uses the properties of solubility and permeability of the drug in the prescribed condition. The original purpose of this system was to aid in regulation of post-approval changes of generics and providing approval solely based on the in vitro data which will be getting based on the properties of the drug. Importantly, the system was designed around the oral drug delivery system since majority of the drugs remain orally dosed. According to the BCS classification system, the drugs can be classified into four types. Class 1, which are highly soluble and highly permeable drugs. Example for this is your paracetamol. The drug dissolves rapidly and is well absorbed in the GIT. Bioavailability problem is not expected in such drugs. The class 2 drugs are your high permeable and low soluble drugs. Example is your aceclofenac. This drug is dissolution limited and well absorbed. Bioavailability is controlled by dosage form and rate of release of the drug substance. Class 3 is low permeable and high soluble drugs. Example is your cimetidine. The drug is permeability limited and bioavailability may be incomplete of the drug if the drug is not released and dissolved within absorption window. Your last class is the class 4 drugs, which is low permeability, low solubility drug. Example is your bifonazole and your curcumin. There is difficulty in formulating this class of a drug product that will deliver consistently the drug in the GIT. There is always a need of alternative route of administration which is needed. To overcome the drawbacks of this class, the last three classes, that is class 2, class 3, and class 4, there are certain approaches when we are planning for oral dosage form. For class 2 drugs, you can use the techniques to increase the surface area, like particle size reduction, solid dispersion, or use of solvents and surfactants. For class 3 drugs, you can incorporate permeability enhancer and maximize the local luminal concentration. For class 4 drugs, we can combine the approaches which we are using to improve the bioavailability of class 2 and class 3 drugs. Next slide, please. There are different methods for improvement of solubility of BCS class drugs 2, 3, and 4. These various techniques are available to enhance the solubility of poorly water soluble drugs. These techniques can be classified as traditional technique, which include use of co-solvents, hydrotropy, formation of solid dispersion, use of surfactant, micronization, formation of inclusion complexes, alteration of pH, or use of soluble prodrugs. There are newer and novel techniques which are nowadays coming in picture, that are your lipid-based solid dispersion, nanoparticulate technology, lipid-based drug delivery system, cryogenic technology, supercritical technology, micellar technology, etc. Next slide, please. Lipid-based drug delivery systems have emerged as interesting vector for oral application because of their potential to improve solubility, absorption of poorly water-soluble drug, and lipophilic drug, slowing down the drug chemical as well as enzymatic degradation, and thereby improving oral bioavailability. 75% of newly coming chemical entities, they are still having low bioavailability, and oral route is the most preferred route for drug administration. Hence, we are going to look at the lipid based drug delivery system, which can effectively deliver proper therapeutic dose to the patient as they present the drug compound in solubilized state, eliminating the dissolution rate limited absorption and improving bioavailability. Also, they circumvent hepatic first pass metabolism by promoting lymphatic system. Next slide, please.
There are various reasons why we should go for lipid-based drug delivery system. There are physiochemical advantages like solubilization of drug aqueous solubility, stabilization of labile drugs against the hydrolysis or oxidation, as your drug will be present in the lipid code. If oxidation is going to happen, it will happen of the lipid and not of your drug. There are certain pharmaceutical advantages like we can better characterize the excipient. We have formulation versatility and choice of different drug delivery system from which we can choose which formulation we can make. There are opportunities to formulate our drug as sustained release product. There are pharmacokinetic advantages like improved understanding of manner in which a lipid is going to increase the bioavailability. Also, we have the potential of drug targeting at the particular site. There are pharmacodynamic advantages like reduced toxicity as the dose is considerably decreased. Then we can have consistency in drug response. Since more than 70% of BCS class 2 compounds exhibit for positive food effects, that is, if you give the drug after you are consuming food, you are getting better drug effect. Therefore, interaction of dietary food in GIT is there, which makes sense to consider lipid-based system for improvement of bioavailability and absorption. Next slide, please. There are various routes of administration by which you can deliver the lipid-based formulation. The first and foremost is oral drug delivery. When we are thinking of oral drug delivery, the lipid which we are going to use are generally from the GRAS system. That is, they are considered as safe and they are approved by US FDA. These lipids which we are going to use, they are considered as dietary material by the body and they will be digested in the same manner as the dietary fats are digested. They get converted to triglycerides and monoglycerides, and these triglycerides and monoglycerides can further increase the permeation inside the GIT. When we are thinking about the topical drug delivery system, certain lipids are there which can improve the permeation from your subcutaneous layer and increase the delivery of the drug when we want on-site delivery for certain skin conditions. Pulmonary delivery. For the pulmonary delivery, we are having nasal route where we are administering SLN and analysis which make use of lipid as excipient for making formulation. It has been observed that nasal route is also a very good route when we want to increase the bioavailability of the drug. When there is no chance of any other formulation or any other route to give our drug, we go to the parenteral route when we have low therapeutic window. So for parenteral route also there are many microemulsions and many SLNs which can be administered. Implantable drug delivery is also available when we want to give on-site delivery for a longer period of time. Here we can have mucoadhesive or thermosetting gels or hydrogels which could be formed using your lipid excipients. Next slide please. These are the different formulation approaches. The number of application of lipid-based formulation has expanded as the nature and type of active drug under investigation become more varied. The lipid-based formulation can be categorized as your emulsions, vesicular system, and lipid particulate system. The emulsions, vesicular system, and lipid particulate system can further be subcategorized into different categories which are listed on the slides, like your nanoemulsion, microemulsion, SMEDs, SEDs, Pickering emulsion, liposomes, transferosomes, neosomes, pharmacosomes, solid lipid microparticles, solid lipid nanoparticle, nanostructured lipid carrier, lipid drug conjugates, etc. Next slide, please. These are the vesicular structures which you can prepare by using lipid as an excipient. Solid lipid nanoparticle make use of solid lipid which will act as a covering for the drug which will be present inside the core. Nanostructured lipid carrier will have two type of lipid, that is your solid lipid as well as your liquid lipid. The ratio of the solid lipid and liquid lipid very homogeneous spreading of the drug which will be present inside the core of your nanostructured lipid carriers. This vesicular structure are resembling to the cell membrane as they are having hydrophobic head and hydrophilic tail. Next slide please. There are different excipients and the rules which are given here on this slide. There are certain lipids. The lipid categories can be done based on the formulation which you are using or based on the application where you are going to use that particular lipid. In case of solid lipid nanoparticle or in case of nanostructured lipid carriers, the amount of lipid which you can use is already prescribed. It is generally up to 30% of weight by weight. So if you want to use lipid, you should know which lipid goes for which type of formulation and what is the role of that lipid in that particular formulation. It has been observed that stearic acid and your tristearine, these are your solid lipid, means they are solid at the room temperature. If you use this particular lipids in your formulation, you could have your formulation which is giving you a controlled release. If you are using medium chain triglycerides or you are using paraffin oil or oleic acid, then the based on the carbon chain they are having, they can act as solubilizers for lipophilic drug. If the carbon chain is less than 14 carbons, then your drug will get like adsorbed to the albumin and your formulation will become more water soluble. If it is more than 14 carbon, then it will increase the permeability in your GI tract. You can use poloxamol 407 or polyvinyl alcohol. These are your hydrophobic emulsifiers if you want to make a formulation. Your span 20, span 60, these are lipophilic emulsifiers. The emulsifiers which you should use depends on the HLB balance. Generally, the HLB 8 to 12 is preferred whenever you are preparing a formulation. There are certain amphophilic emulsifiers like your egg lecithin or soya lecithin. These are also coming under the category of lipids. This can act as your co-emulsifier in your formulation. Next slide, please. Here there is a case study of your nano curcumin where you have used curcumin for formulation. Depending on the ratio of lipids which they have used and the different excipients which they have used, it is scientists were able to make different formulations of curcumin, starting from your nanogels to inclusion complexes, phytosomes, solid lipid nanoparticles, normal curcumin nanoparticle, curcumin solid dispersion lipid particles, etc. Next slide, please. There are different methods for preparation of lipid-based formulation. The methods which are listed on the slide are the most commonly used methods. One is your high pressure homogenization. Here you will be heating your lipid at suppose 70 degrees Celsius, which will be your melting point of your lipid. Then if your drug is oil soluble, you will be putting it in the lipid and you will be adding a solution of surfactant in water on the other side, which will also be heated at the same temperature. Then at very high pressure you will be mixing both this solution to form an emulsion. There is other method that is that is ultrasonic emulsion evaporation. Here you will prepare a micro emulsion, and this micro emulsion will be then put into ultrasonic probe to decrease the particle size further. Then there is solvent dispersion method where you will be evaporating the solvent and you will be getting small particle size of your formulation. The other one is film ultrasonic method, which is generally used for preparation of your liposomes. You can prepare your solid lipid nanoparticles and nanostructured lipid carriers by your microemulsion technique and supercritical fluid method. And it depends on what material you are using and what is the particle size range you want to have for your final product which you have in your hand. Next slide, please. There are different methods for characterization of your lipid based formulation. These methods are categorized into three types, namely spectroscopic method, microscopic method, and your thermal analysis. Your spectroscopic method includes your UV, FTIR, powder XRD, Raman spectroscopy, NMR, etc. This gives you idea about the doping, the concentration, the purification, of your, you get the idea about the thickness, number of layer. There is high resolution imaging, atomic number constant, surface properties you get to understand, composition, morphology you get to understand by doing your microscopy. When you are doing your thermal analysis like your TSC, TGA, TMA, you get the idea of what the carrier and drug interactions are, about the crystalline or amorphous nature of your drug particle or of your excipients. There are certain other methods which are used to characterize your formulation. These are your dialysis method, bioassay method, chemical analysis method, which help you to study the release profile and drug loading capacity of your formulation. Next slide, please. Lipid based formulation, though we are thinking about it from last 5 to 10 years, but many formulations were already present in the market. Some of them are made by AstraZeneca, Abbott Laboratories, Novartis, Bristol Myers Squibb. The product names are given with the drug they are having and the type of formulation they are preparing. You know that lipid based formulation you can prepare as normal solution to your suspension emulsions, ranging different type of formulation. So I tried to include one type of formulation each from a well known company in the market. Apart from pharmaceutical uses, there is cosmetic use of this lipid based formulation as well. For example, your Olay brand, which is a skincare giant, it is making use of nano emulsions. And there is another brand that is Cutanova, which is having quercetin 10 loaded nano pearls. It is making nanostructured lipid carriers, which they are marketing in the market. Next slide, please. Apart from the marketed product, there are various patents which are filed based on the lipid-based formulation. These are certain patents which which I have got based on the lipid excipients which were used for making formulation. Some formulation were liposomes which were made by Milton. The other formulation was neosome hydrogel delivery system, which was filed by University of South Florida. They have the first patent which uses lipid nanoparticle, and they have changed the composition and method for delivery of biological active drugs, which might be even your mRNA delivery system. Next slide, please. Okay. So finally, coming to the conclusion of today's presentation, we have discussed about the lipid-based formulation. We have learned about what type of lipids we can use, as these lipids are, we have come to know that these lipids are highly versatile and they can address the low bioavailability, food effects, and low dosing, high potency, API solubility, and other formulation challenges which are there. When we look at the lipid based formulation, we require careful system characterization, which is necessary before starting the manufacturing work, as well as when you are doing formulation. We should select proper excipient, but also we should look at which method you are going to use for formulation of your uh, product. While certain aspects are there, like your API processing or coating, which might be challenging, there are various scale up challenges which are present in your lipid based formulation. If you consider looking at the regulatory perspective, your lipids, they are prone to peroxidation. So every time when you are preparing a lipid based formulation, you should also do the study for peroxides. Apart from that, there is no standard book where you get the which lipid you have to use. So each every time you have to do proper literature survey, you should have proper toxicity data. So generally formulators are using the lipids which are earlier used by other formulators, or which were earlier proven non toxic or non irritant when they are given by that particular route. Apart from that, the other thing they are doing is they are referring to the CFR data they are following to get the proper regulatory compliances for the formulations. Okay, so with this we come to a conclusion of the today's presentation. Next slide. There are certain processes which I have used for preparing this presentation. If anyone has any queries, you can ask me in the comment section. Otherwise, I will wrap it up here. Okay. Thank you everyone for your attention, and thank you for being present with me for this session.
Good morning, everyone. It is my pleasure to propose a vote of thanks for our today's session. I would like to thank our eminent speaker, Ms. Apurva More ma'am, for enlightening us with her knowledge. Today's webinar provided us with a very so much knowledge, like introduction to the lipid formulation, BCS classification, methods how to enhance the solubility, then patents, like South Florida has a patent of lipid-based formulation of neozen and hydrogen. I would like to thank Apurva ma'am for a knowledgeable session. Thank you all. We will be continuing with another session soon. Do not leave the class.
Thank you everyone for your support.